So today we are starting a new area of study, matrices and graph theory. It's chapters 11 and 12 from the textbook. And first of all, we start from matrices. It's a small topic, so start will be in week 2 of the term 3. So, matrix. What is matrix? Matrix is rectangular arrangement of numbers. For example, 3, 1, minus 5, 0, 10, 1/3. That is matrix. Rectangular arrangement of numbers. Matrix has, say, order, which is m by n, where m is number of rows and n number of the columns. So what will be the order of this matrix?
Is it like
how many rows we have?
2 times 3.
2 rows, 3 columns, so this matrix will be of order 2 by 3. You say 2 by 3.
Okay.
Matrices has a lot of applications. Fortunately, quite a few of those applications were removed from the curriculum from methods. They were actually very useful and helpful with the functions and graph transformations. They were very helpful. There were applications in probability. Again, it was all removed from methods, so no more matrices in methods. And there is no matrices in 3-4 special, only in general, 1, 2, and 3, 4. Now, a little bit of terminology. Matrix can be square. Square if it is a same number of rows and columns. So a square matrix. For example, 2 by 2, 3 by 3, and so on. By the way, what we learn how to apply matrices to solving simultaneous equations, which actually might be useful, which you can apply for tech-active things when you need to solve more than 2, 3, 4, 5 simultaneous equations at the same time. Matrices are very helpful with that. Square matrix, then null matrix is when all elements are zeros. Diagonal matrix, if we have numbers only on the diagonal, let's say 2, 3, 5, everything else are zeros. Again, it's applicable to the square matrix, is diagonal matrix. And one diagonal matrix which has ones on the diagonal, everything else is zero. And can be 2 by 2, 3 by 3, 4 by 4. But when things all 1, everything else is 0. It's called identity matrix, denoted with a capital letter I, called identity. It plays a role of a number 1 among numbers.
So what is the number 1? Is it the identity?
Only has to be on the diagonal.
Oh, okay.
Once, everything else is 0. Next lesson we will learn more about this. Yes?
Can it be the diagonal the other way?
Identity matrix only this way. Now, there are a lot of other names for matrices, different types, but which are in general, but we're not looking into that. That is just this called this called this called this. We don't need that. Matrices denoted with the capital letters. So let's say maybe matrix A. And we can do mathematical operations, arithmetical operations with the matrices. We can add, subtract matrices. We can multiply matrix by a scalar or by number, and we can multiply matrices. We cannot divide matrices. There is no division of matrices. Now, to add or subtract matrices, they must be of the same order. So, if we have matrix A is of order 2 by 3, we can add or subtract on a matrix B, which will be of the same order. If they are different order, we cannot subtract. Now, element of the matrix, we denote it with the lowercase letter a and put I, J, where I is in which row it is, J in which column. So, for example, again, if we have matrix A equal, let's say 2 by 3, 1, 3, minus 4, 0, 1/2, 2. So what will be element A, 2, 2? Second row, second column is 1/2. And if the matrix B will be of the same order, 2 by 3, for example, minus 4, 0, 7, 1/5, minus 1, 3. To add matrices, we add the corresponding numbers. So we need add A11 from here with B11. So we will have 1 plus negative 4, negative 3. 3 plus 0, 3. Minus 4 plus 7, 3. 0 plus 1/5, 1/5. Minus 1 plus 1/2, negative 1/2. 3 plus 2, 5. That will be matrix A plus matrix B. Make sense? Very simple. If you subtract matrices, we subtract the corresponding numbers. So it will be 1 minus negative 4, will be 5. 3 minus 0 will be 3. Minus 4 minus 7, negative 11. 0 minus 1/5, negative 1/5. 1/2 minus negative 1 will be plus 1, so 3 on 2. And 2 minus 3 will be negative 1. That's how we add, subtract matrices. We can multiply matrix by the number. If you multiply, for example, matrix 2A, that means we multiply every number in the matrix by 2. So that will be 2, 6, minus 8, 0, 1, 4. Let's find the result if we do, let's say, 2A minus 3B. 2A, 2 minus 3B, that will become negative 12. 2 minus negative 12 will be 14. 6 minus 0 will be 6. 8 minus 21.
It'll be 12.
Which 12?
It's 2A.
No, that's 2A.
Oh, yeah,
So
well,
2A is 2
Yeah.
minus negative 12. It's 2A minus 3B. So multiply everything with B on 3. Now we have minus 8 minus 21 negative 29, 0 minus 3/5, negative 3/5, 1 minus negative 3 will be 4, and 4 minus 9, negative 5. So this is all very simple, can be easily done by hand, no calculator required. But still, let's see how we operate with the matrices with the calculator. So with the TI, to make matrix, wake up.
Maybe it's dead.
So you press menu, then you have number 7, matrix and vectors. 7, matrix and vector. And then we press 1, create. And we want to create one matrix, 1. And press enter, and it's asked us what size of matrix we want. Let's make it with the this one. So we want 2 by 3. So you change number 2 by 3. And press OK. And it gives you the arrangement with the empty boxes. So let's put this matrix in. 1, 3, negative 4, 0.
Basically, I get it's like I get what it is, like a rectangular whatever. Example, what is it used for? Like just like a table. What is it?
Matrix is what it's used, as I'm saying. They used for functions and graph transformations, very useful and powerful tool, which was removed from the
Yeah,
curriculum.
but like in mathematics, where is it used?
Mathematics, that's what I'm saying.
Okay.
Used for solving simultaneous equations, which you'll learn later on, when it's like more than 2, 3, 4, 5 simultaneous equations. Matrix is very useful.
Okay.
Also in probability used. Also with the graph theory, which we will next. So that are the sum of the applications of the matrices. There are quite a lot. But unfortunately, pretty much everything was removed from the curriculum by matrices. So, but in 3/4 there is no matrices. So that we create matrix, then we need to give it some name. To give it name, you press control variable, and then so press control variable, and let's say A, letter A, and enter. Now calculator will know that this is matrix A. Create matrix B. In the same way, create matrix B with your calculator and calculate uh, 5B minus 4A using calculator. Then you do, when you create, you just press 5 times A minus 5 times B minus 4 times A. So you need to create matrix. give it name B, and then do 5 times B minus 4 times A.
Yeah.
You got it? So, yeah, what the answer?
Negative 24, negative 12, 51, 1, negative 7, and 7.
So it's pretty easy to
Yeah.
operate. Now, so those operations are pretty simple. Multiplication of matrices is much more complicated. So, when we need to multiply two matrices, their order must, by the way, two matrices are equal only when they have same order and every corresponding numbers are equal.
Can we times the matrix by itself?
Yes, we can put matrix in the power.
Okay.
That is multiplication of the matrix, and that's what I'm explaining now. So if we have matrix A, m by n, we can multiply it by matrix B, n by whatever, let's say, P. So we can do A times B. It must be number of the columns in the first matrix equal number of the rows in the second matrix. And the order of this matrix will be M by P. This will go. But even if the matrix is A plus B, if it's possible, it's equal B plus A. Not with the multiplication. In this case, it's not just AB will not be equal BA. BA does not exist. BA not exist.
How come? Because it doesn't have the number.
Because we have number of the columns in B does not equal number of the rows in the first. And in general, even if we can multiply AB in matrices, even if they both exist, AB and BA, they don't equal. They don't equal. AB times B, A times B does not equal B times A. If BA, if they both exist. What should be made for what matrices they both will exist?
What do you mean?
For square matrices. If they both, let's say, 2 by 2 or 3 by 3, square matrices, it's always will be possible. Simple. Now, how we multiply? By hand, we will be multiplying only 2 by 2. We will not be multiplying matrices, let's say 3 by 3. It will take, probably I will not fit it in the whole board to multiply 3 by 3. So that will be done with a calculator. So how we multiply matrices? So if we have matrix A equal A11, A12, A21, A22. Remember, first digit is a number of the row, second number of the column. And matrix B equal B11, B12, B21, B22. Then AB, A times B will be equal. What will be the order of the resulting matrix?
A11, B11.
No, they both 2 by 2, no order. What will be the order?
Oh, for.
This is 2 by 2 and this is 2 by 2. What will be the result?
2 by
2 by 2. It still will be 2 by 2. How we multiply? To get the first one, we multiply first row by first column. So we will have A11 times B11 plus A12 times B21. For second one, we do second row by first column because this is in the second row, first column. So we will have A21 times B11 plus A22 times B21. We multiply, this is in the second row, first column. So we multiply second row by first column.
Okay.
This is first row, second column. So we multiply first row by second column. We have A11 times B12 plus A12 times B22. And this will be second row multiplied by the second column. So A21 times B12 plus A22 times B22. So you always look which position you're looking for, and you multiply appropriate row by appropriate
So you
column.
never touch the second row of the first matrix?
What do you mean?
You never
Here,
Oh, we
this,
touched it. Okay.
this is second row. In this row, we do second row times first column, A21.
And then second row, second column.
This is second row, second column.
Okay.
First row, first column.
Mm-hmm.
First row, second column. Second row, first column. Second row, second column.
Okay.
Make sense?
First row. First column.
Now, by hand, let's multiply the next two matrices. Multiply matrix 3, 7, minus 1, 5. Multiplied by identity matrix 1, 0, 0, 1. Using this method. Multiply this matrix by the identity matrix. Using this method. So first row by first column, first row by second column, and tell me what you will get.
My God.
First row
Yeah.
by first column, 3 times 1 plus 7 times 0.
It's just the same as that one, right?
Yeah.
Yes, it will become the same matrix. That's what I mean when I say the identity matrix play like a role of number 1 for numbers. When you multiply by identity matrix, you will get the same matrix. Or if you swap them, we'll get the same result.
Oh, so if you times the matrix by the identity matrix. then-
You will get the same matrix. We will see how it will be helpful with the solving equations later, with simultaneous equations. We'll learn a little bit later on. Now let's do small calculator exercise. Let's make two 3 by 3 matrices. Let's say matrix A equal 1, 3, minus 1, 2, minus 5, 0, 7, 10, 2. And matrix B, create them in your calculator, both matrices. And 2 minus 1, 11, 13, 15, 15, minus 5, 3, 4, 5. and multiply matrix A by matrix B. Create in the calculator matrix A, matrix B, and then just do A times B.
Yeah.
And-
It stays at 3 by 3.
You need to create 3 by 3.
Yeah, no, and it stays at 3 by 3. So it's Wait, what happens if you have a matrix that's like 1 times 2, and your second matrix is 2 times 4? How do you multiply that?
If you have 1 times 2
And
times by 2 by 4, resultant matrix will be 1 by 4. With these two go, and we have 1 by 4.
but how do you do it? Like, because there's an example here, and it's calculated 8 times 3.
What? Let's finish with this one. I'll do this.
Yeah.
So you've done? Excellent. What the answer? 8 times B?
38.
Hmm?
38. 40. Negative 9. Negative 61. Negative 77. 47. 150. 151. 37.
Sorry, last
37.
37. Now do B times A, and you will see you will get completely different.
Yeah.
If you do B times A, you will get completely different result. So in matrices, order in which you multiply matter. Now that example that everyone fine with that? How to multiply matrices with the calculator? So is the given matrix there? See.
No, I just made up a matrix.
Okay, let's make 1 by 2. Let's say 2, 3. 1 row, 2 columns, and 2 by 4. So we have 1, 5. We have 2 rows, 4 columns. 1, 5, 4, 2, minus 1, 3, 2, 0. So when we multiply them, we multiply first row by first column. 2 times 1 plus 3 times minus 1, so minus 3. Then we do again first row by second column. 2 times 5 plus 3 times 3. Probably not enough from here. So equal 2 times 1 minus 3. 2 times 5 plus 3 times 3. Next again first row, third column, 2 times 4 plus 3 times 2. Then first row by the fourth column, 2 times 2 plus 3 times 0 is 0. So resultant matrix is 1 by 4. We have 2 minus 3 minus 1, 19, 14. So we got matrix 1 by 4. Okay, that's all theory for today. Like, subscribe and donate to help fight terrorist countries and organizations. Support Ukraine and Israel.